Imagine this, a region of space so empty, so vast, it feels like the ultimate void. No planets, no stars, no galaxies, just pure nothingness. But what if I told you that even this so-called emptiness is brimming with something invisible, something so powerful that it's driving the universe to expand faster and faster every second? This isn't science fiction. This is the incredible reality of empty space. And by the end of this video, you'll discover how this unseen energy could hold the key to the ultimate fate of the universe. Stay with me, because what you're about to learn will change how you see, well, nothingness. When we think of space, most of us picture vast blackness, a cold, silent expanse where galaxies drift apart and stars burn out. But the truth is, space isn't empty at all. Even in the darkest, loneliest parts of the universe, where no light reaches, something extraordinary is at play. Scientists call it dark energy, and it's not just sitting there doing nothing. This mysterious force is actively shaping the cosmos, stretching it out like an infinite rubber band. But how did we even figure out that empty space isn't so empty? And what does this mean for us, for Earth, and for the universe itself? To answer these questions, we'll take a journey through mind-bending discoveries, from Einstein's equations to cutting-edge space telescopes. Buckle up, because understanding the universe's most elusive secret will leave you questioning everything you thought you knew about reality. Let's start with a mystery that baffled scientists for decades. If the universe began with the Big Bang, a massive explosion flinging matter outward, why isn't it slowing down over time? You'd expect gravity, that ever-present force, to pull everything back together, or at least slow the expansion. But when astronomers measured distant supernovae in the 1990s, they made a shocking discovery. The universe isn't just expanding, it's accelerating. This was like finding out a car rolling uphill is speeding up instead of slowing down. Something had to be pushing it. Gravity doesn't work that way. And so the concept of dark energy was born. But what is dark energy? Why is it so elusive? And why can't we just measure it like we measure a star or a planet? To understand dark energy, we first need to dive into the nature of space itself. Einstein's theory of general relativity tells us that space and time are not rigid. They're like a flexible fabric that can stretch, bend, or even warp depending on the presence of matter and energy. But here's the twist. Einstein's equations also hinted at something unexpected: an inherent energy within the fabric of space itself. At first, Einstein dismissed this idea, calling it his biggest blunder. He introduced a term called the cosmological constant to balance his equations, but later abandoned it when the universe was thought to be static. Fast forward to the 20th century, and that blunder turned out to be a stroke of genius. The cosmological constant perfectly explains the accelerating expansion we observe today. But wait, there's more. Quantum mechanics, the science of the very small, also has something to say about empty space. According to quantum theory, a vacuum isn't truly empty. Instead, it's a seething sea of particles popping in and out of existence. These virtual particles might be tiny, but their collective energy adds up. Some scientists believe this quantum vacuum energy could be the source of dark energy. Still, there's a huge problem. When physicists calculate the amount of vacuum energy predicted by quantum mechanics, the number they get is ridiculously huge, about 10 to 120 times greater than what we observe. That's the number 1 followed by 120 zeros. It's one of the biggest mismatches in all of science, and no one knows why. Here's the jaw-dropping part. Dark energy isn't just some abstract idea. It makes up about 68% of the universe. That's more than 2/3 of everything in existence. Compare that to dark matter, which accounts for about 27%, and ordinary matter, everything we can see, touch, or measure, which is a measly 5%. This means that the universe we experience, from stars to planets to galaxies, is just a tiny fraction of the cosmic puzzle. Dark energy is the dominant force, quietly pulling the strings of the cosmos. But here's the kicker: dark energy's influence is only growing. As the universe expands, it creates more space, and with it, more dark energy. This leads to a feedback loop where expansion begets more expansion. If this continues unchecked, we could be headed for a Big Rip scenario, where the universe's fabric is stretched so thin that galaxies, stars, and even atoms are torn apart. So what does all this mean for us? Dark energy is a reminder that the universe is far stranger than we can imagine. It's a force we can't see, yet it shapes everything we experience. It's a mystery that challenges our understanding of physics and reality itself. And while we may not have all the answers yet, one thing is certain. The more we learn about dark energy, the closer we get to unlocking the ultimate secrets of the cosmos.